Welcome to qnawire.
Okay, we got a calculus problem here. Graph of the first derivative of the function is shown below. So here's our graph of the first derivative of our function. On what intervals is the function of f increasing, and why? Well, what do we know? I'm going to grab a pen here to draw with. What do we know about a function that's increasing? When the function is increasing, the slopes of the tangent line are positive. So where are the values for this first derivative positive? Well, looks like from here, from 0 all the way to 4. There's one place where our function would be increasing, because these values all coincide with the slopes of the tangent line, and since they're all positive, that means they're going up to the right, which means it's increasing. Another place would be from, let's see, 6 to 8. Again, the values of the first derivative are positive, so that means the function is increasing. Okay. Part B, at what values does x have a local maximum or minimum? Okay, so remember when we were thinking about, when you're looking at your functions, and we were talking about a local max or a local min, that was where, if you had your graph, it was where you either had a peak, like, it goes up then comes back down, or a local min where it goes down and comes back up. Now, where do we find that in the first derivative? Remember, like, for example, if I had a graph, we'll just do a little upside down parabola like that. If this is our graph. Okay, so we've got some sort of upside down parabola. Up here where there's the maximum, the tangent line, the slope of the tangent line is 0. Okay, and so where does the graph cross the x-axis? Well, right here at 4, and right here at 6, and right here at 8. And so over here, remember we just said that here it was increasing. So that must mean our graph's going up, going up, going up. Right here at 4, we have a slope of 0 for the tangent line. So that means it stops. And then down here, notice we have negative values for our first derivative. So that means the graph is decreasing, so it's going back down. So this is a possible max. And eventually it gets to the bottom. And so here is where at 6, we're going to have a min. At 4, we're going to have a max, and then this means it's decreasing down to a point. So at 6, we'll have a min. Then it's increasing again, because here the first derivative is positive, so that means the slopes of the tangent line are positive, so it's going up. So right here, we'll have another max. So maybe a local max, a local min, a local max. Okay, that was fun. Now, at what interval is f concave upward, or is f concave downward? Let me pause my video for a second and erase everything, and then we'll look at that. Okay, hold on. Okay, I erased everything. So now we're looking at concave up and concave down. Now, if you've been paying attention in the chapter, it's concavity comes from the second derivative. So now we're talking about the slopes of the first derivative. The slopes of the tangent line of the first derivative is what we get from the second derivative. So let's see, over here we've got a positive slope. So that must mean it's concave up there. Over here we've got a negative slope. So that must mean it's concave down. Over here we got a positive slope. That must be concave up. Over here we got a negative slope. So it must be concave down. And so forth. Positive slope, negative slope. So let's see. At 1, at 2, at 3, at 4. They're all changing. So from 0 to 1, 2 to 3, 5 to 7, those are concave up, and the rest are concave down. And then the inflection points, I think I was circling them. The inflection points are where we get a slope of 0. So there's a inflection point because we go from concave up to concave down. Here's a point of inflection because we go from concave down to concave up. Here's a point of inflection because we go from concave up to concave down. Okay. Here's a point of inflection here at 7 because we go from down to up. Oh no, that's 5. Excuse me. That's 5. From down to up, and then here between 6 and 8 at 7. This is where we would go have an inflection point because we go from concave up to concave down.